Good morning to everyone. I'm going to do the most important things just done in the session 2 in strength of materials. As you can see in the title, this video is because of the session 2 of strength of materials, and the only thing you have to do download it is that journal file that you have just downloaded in session 2 from the platform. So you don't need to download it again. Instead, you have the file changed from the session 2 and you want to do new again. So the first things we have to do is to open Abaqus CAE as always, and select the set word directory as always. In my case, I'm going to download it in desktop, session 2, okay, a folder called session 2. Okay, and now in the journal file, in order to be able to be read from Abaqus, you need to change the language. Okay, I don't know if you're going to open Notepad++ in Spanish, but the the icon you have to click on is language, okay? And then you have to look for the letter P in order to open Python language. Okay, now we can see clearly different colors, and this code is the creation, the modeling of the bridge done in session 1, okay, with code in Python language, okay, which Abaqus can read. If we click on File, Run Script, okay, we can find this file but in a Python script. So what we have to do is archivo, save as, or guardar como. We can call original bridge but in Python language. Save, and then we can find this code in Abaqus. So if we can see, we have one part for materials because I created, in this case, the 3 types of steel. And then we can see our bridge with the loads, boundary condition, and everything, okay, read by Abaqus. Okay, the first thing we are going to do is to see how this kind of codes can work regarding parameters. For example, I can create a parameter of the Young modulus for the steel 1, which its value is 210 gigapascals. So instead of writing the number, we can write parameter. Okay. And the value can be written in the beginning of the code. So this kind of things is used when we can change a specific parameter. For example, if we are changing the profile of the main beam, for example, we can write at the beginning the parameters in order to find it easily. To find the different parameter we want to change easy. For example, if we want to change the thickness, we can write here T equals 0.02 meters, and then in the thickness only writing T, for example. Okay, it's the same. That is only the beginning, and now we are going to do something useful for you and for your reports. because in your report you have to add a specific exercise, which is to graph a graph in which you have to compare the number of elements in your main beam and in your pillars, okay, because you have to do in the examples done in the session 1, not in your own bridge. Remember that you have to do this exercise, the exercise related to the session 2, in your in the example of the bridge, okay, in the example of the bridge, because you only have this code, and this code is related to the example, okay. So you have to compare the number of elements with the von Mises stress obtained in the results, and the number of elements compared to the vertical displacement, okay. So in this exercise, in this video, I'm going to do more or less the same, but changing the load, okay. You have to do the same, but not with the load, with the number of elements. So the first thing I'm going to do is to write the load here as a parameter. For example, 60,000. Why 60,000? Because in this exercise, we are going to simulate 10 different simulations in a row. 10 different simulations in a row, changing the load, incrementing its value 10,000 each time. So if we increment this value 10,000 each time, the simulation number 10 will be simulated using a load which value will be 150,000, which is the value done in the session 1. So now we are going to create a loop for with this parameter called I in range from 0 to 10. And then the rest of the code, we are going to click on Tabulate button in order to get the rest of the code into the loop, okay. And if we want to increment the value of the load, we have to do this kind of things, okay. We ensure that the line is inside the loop, okay. Q equal Q plus 10,000, okay, in each loop, okay. The first loop, the value of load will be 60,000, the second loop 70,000, 80,000, 90,000, but the lines related to the line load, okay, we have to change the value of the load for a Q, okay, minus Q, minus Q, okay, minus Q, because we didn't write the value in negative, so minus Q. Now we are going to create the lines that will work as a I don't know how to say, in order not to only create one simulation, but create 10 different simulations. 10 different simulations in a row, and each simulation will have different value for Q, for the line load. Okay, we have to write something like that. Okay, and you have all these lines. Okay, remember that you have all these lines in the guide, in the platform. Job name equal simulation underscore plus string, which is a language of Python, string I plus 1, in order to write 10 different simulations. In the first loop will be the simulation underscore 1, second loop simulation underscore 2, third loop simulation underscore 3, and again up to simulation underscore 10. So we have to rewrite the name of the job okay, and call it job name. Okay, job name. Doing that, the simulation number 1 will be done with a value of 60,000. The 2 will be done with 70,000. If we don't write this last code line, okay, the code will only simulate one simulation with a value of the last one in the loop, with the value of 150,000, but only one. If we want to create 10 different simulations, we have to write this code, okay? So what is the last thing we have to do? The last thing we have to do is to write the lines related to the job. And these lines you have on the platform, which are those 3 lines. Okay, so mdv point jobs, job name. Be careful with the characters, okay, with the letters you write, okay. It's very easy to make a mistake. Write input parentheses md job b point jobs, job name. Be careful with the capital letters. Submit, and between parentheses consistency checking equal off. Last one, mdb point jobs, job name, point, and I need to remember, wait for completion. Okay, be very careful with the characters, the capital letters, and everything. Okay, the first one is not written with capital letters, but each time a new word starts, the first letter is in capital letters. So that's all. And if we have done everything well, if we run this code, I'm going to save as changing load. Abaqus are going to read this code and simulate 10 different simulations in a row. New model database with a standard explicit model, in order not to rewrite what we have read before. So run script, changing load. Oh, we have made a mistake. Okay. If because we removed the parameter e underscore still underscore 1, but I continue writing the parameter instead of the value. So that is the mistake. New model database, run script, changing load. Okay, it's running. Okay, so while the Abaqus runs the 10 different jobs, we are going to create something useful not only for this exercise related to the example of the session 1, but also to write a code for your own bridge, your optimized bridge. And it's useful to save a lot of time creating different sections and different profiles for the main beam. Okay, it's very, very useful for doing that. So what we are going to do, we are going to change the language as well, Python language. We are going to save as, and we are going to call it sections. Okay, I'm going to teach you how to create several sections in a row in order to apply one of each section to one trash bar. And if, for example, in your job, in your simulation, this bar does not reach the limit or even is supporting too much stress, you can create 10 different values for this section in order to find the best one to optimize the weight of your breeds instead of creating manually each section. Okay, so we are going to copy the part related to the section of the thrust bars, which is this one. Okay, thrust bars made of steel one. And also we are going to copy the lines related to the I section to assign the main beam section. Okay. Then we are going to create a loop in range 0 to 50, for example. Okay, 50. We are going to create, okay, before the loop, we are going to call two different parameters. One is going to be the thickness of the eye profile, which is going to start by 0.01 meters, which is the limit, okay, the minimum thickness for the profile related to the main beam. And then another parameter, which is the area of the section, the thrust bars, okay, this one, which is going to start by 0.0005, again 5, for example. Okay, 10 times less than the sections created in the session 1. Then in the loop, we are going to increment this value for the thickness, t equal t plus 0.01, for example, and no, 0.01, okay, which is going to be incremented 50 times. So the last one will value like 0.06, I think. The area incremented to 1. Okay. Now we are going to change the values, rewriting the parameter. But that is not all, because if we only run this code, we only will have one section and one profile with the last value of the loop, So what we have to do is to change the name in order to create 50 different names with its specific value for the thickness and the area. So inside the loop, a name, for example, or section thrust. No, a name is okay. A name equal to thrust section underscore plus string y plus 1 and tname equal thickness underscore plus str y plus 1. Okay, name. And then instead of name, tname, and instead of this name, a name. So doing that, we will have 50 different sections for a name for the thrust section and 50 different thickness in the profile, in the main beam profile. But if we can identify which section corresponds with its name, we can do a trick, which will be not called thrust section underscore 1 to the first one, but call transaction underscore 0005 to the first one. And in the number 2, instead of call it 0002, call it 001, which is what will be the cross-section area. So instead of call it transaction underscore 1, doing that, okay, okay, the first one will have the name transaction underscore 0005. Okay, but the second one will have 2 multiplied by 0005, which is what will be the value of the cross-section area. So if we save this file and we focus on the number of section and number of profile, we are going to run this last script, and then we have 54 different sections because we had 4 and 50 more. And if we check transaction 0.0 and the value of the thickness, for example, transaction underscore 0.022, we have a section area of 0.048. Okay, there is something wrong in the code. I don't know when, but there is something wrong in the code. Okay. Because we don't have to. Okay, because we are not incrementing the same value. Okay, if we increment the same value, we can multiply the value of the initial thickness, but we don't incrementing the value. We are incrementing. Okay, so we can solve that if we change the equation, okay, in order to be able to call each transaction, okay, underscore the thickness of the transaction. For example, the second transaction, I think that will be incremented by 0.0005, but not, will be incremented by 0.00001. Okay, so doing that, we are doing something wrong. So if we think on the fly how to do it, we can, okay, the second one will have 0006. So it's impossible to multiply this one. But if we do something like that, the first one will have 0005. Divided by 0005, and the second one, okay, the first one will be like that, and two plus 0001. Okay, we are thinking on the fly, so if the underscore number 1, okay, will have a section of 0.0005, the number 2 will have 0006. So we need to call it like the 1 plus multiplied by this plus this. If we do that, file, new model database with standard split model. No, we are going to delete everything in order not to run all the code. Okay, so we are going to delete all the sections. Okay, doesn't mind that the trash bars don't have a section. I only want to show you how to create the sections with the same name of the area. Okay, delete the assignation, and then again, and now the section. Oof, almost. We have to incrementing, doing like that because it starts from 0. So since it starts from 0, we have to increment a bit more. Okay, since it starts from 0 to 50, okay, the first one will value 0 multiplied by blah blah blah, and then run script sections. Now that's it. Okay, that is only a tip in order to call your sections, okay, using the name of the cross-section area. Doing that, we have created 50 different sections, okay, and we can use or not use this section, but we have just created, okay. So if my simulation, in my simulation, I have one bar with this section, and it almost reached the limit, we can decrease its value in order to be closer of the limit, but not below the limit. Okay, so now we are going to analyze the different simulation we ran before. For example, the simulation number 1, remember that will have a value of 60,000. Okay, have a value of 60,000. So since it has a value of 60,000, if we click on results, the von Mises stress is 160 megapascals. But if we analyze, for example, the simulation number 10, which have the highest value of the line load, which is 150,000, the von Mises stress is 41.6 megapascals. A simulation in the middle, for example, this one, which value is, I think, 60, 70, 80, 90, 10, 100,000 Newton per meter. Its value for the von Mises stress is 267 megapascals. Okay, doing that, we can graph a value in which the y-axis will be the von Mises stress and the x-axis will be the line load. In your case, you have to do the same, but with the von Mises stress and number of elements. Okay, number of elements, this parameter. Okay, and another graph using the y-axis, the vertical displacement, and the x-axis number of elements. Okay, that's all, guys. That's all. I have to say sorry because of that little mistake, but it's useful as well for you in order to think how to call the different section in order to identify each one. Okay, so bye bye.